Firstly, do you see the text?
Yeah.
Projector?
I guess.
Is it small for you in the back?
Yeah. Too dark. It's blurry.
Is it too dark? No, it's not too dark.
Yeah.
Is this better in the back? Yeah. Okay. Cool. Do you also see my face? I mean, it doesn't matter, I will be looking all the time to the computer. I just wanted to ask, is it compatible with Python? So, let me start with a round of questions. Who of you knows what unit tests are?
Come on.
Okay, cool. Who of you is a developer who unit tests their code? Okay, lesser hands. Who of you would like to do that? Who of you is a tester of some kind? Okay, cool. So I think pretty much all of you is in target audience. By the way, I should introduce myself. My name is Jan. I used to work at IBM. Now I work at Red Hat, and I have a feeling I will be working at IBM soon enough.
Relax.
So, okay, cool. Today I will be talking about pytest. So, I don't have any presentation on what it is. I would actually like to show you, and I have something which can be called almost live demo. You will see why it is almost, because it's kind of faked. I would be too nervous to use my fingers right now, so I will be just playing some code as it goes.
Okay.
So,
stub.
Excuse me?
It's a stub.
Huh?
Yeah. It's a stub of live demo.
Yeah, it's kind of like this, like a child of live demo. So, what is pytest, you may ask? It is an open source testing framework, and what it can do for you. Imagine that you have your own application, your own program on GitHub, let's say, and you want to unit test it. So why would you do that? You would do that so whenever you make some change to the code, you want to make sure that you didn't break the previous functionality. So that is definitely one use case. Why would you be interested in pytest? Another use case is that you may have like big program, big enterprise solution. For example, like Úvod, that is a Red Hat product which I work with, which is very mature product that has been many years in development, and you need to write maybe hundreds, maybe thousands of different test cases that verify resilience of the software. So in both cases, you need some logic behind your tests. You need something to schedule your tests and make sure that the order of the tests makes sense. Something that makes sure that all the prerequisites are in place before some tests can be run, and something that also cleans up after itself, after everything is done, and also importantly, something that reports the outcome of the tests in a clear manner. So is that clear for you? Do you have some idea what this might be from this short description? Okay, there's a question.
Yeah. Why is the order of the test important?
So let's imagine that you have like some virtualization solution like over this, and firstly you want to execute test that a VM can be created, and then you want to execute test that VM can be deleted. So you see why the order is important, because if you schedule those tests in random order, it doesn't make sense. You first want to create the VM and then to delete it. That's like kind of naive example, but that's the basic idea behind it.
So because like I used to do like that, and then there is some people say that you should not rely on other tests' outcome to take that as a scenario to your next test.
That's true. That's very much true, and that's why pytest uses something that is called fixtures. You don't actually rely on the previous outcomes, but you specify what you need to have in order for your tests to run. I will demonstrate that in a short while. So first, before I get to the almost live demo, I will show you my simple application that I prepared here. It's called Country Parser, and it works in simple fashion. You give it some JSON with data about country. So here in directory example data, I have country by population. And it's just simple JSON that can be downloaded from GitHub from one guy who maintains that repository. And it includes quantitative data about countries. If you want to use Country Parser, you just call it with data dir and say where the data are. So in our case, example data, you choose category. So in our case, it will be population, but there could be many other JSONs with other statistics. And then you can either choose highest, which will give you, of course, the highest entry in the JSON. So what will that be for countries in the world? China. Yeah. So you can also do lowest. Are there any tips? I've heard Antarctica, that's true. I guess nobody has permanent residence there.
Look at the screen, you can't see the start of the lines. Could you make the window smaller?
I may try. Can you see the end of the line?
The start we can see.
Yeah.
Yeah, we can see the start.
Yeah.
Thank you.
It's okay.
No, it's still not good.
Oh, it is good.
It's fine. Oh, yeah.
Okay, we're there. Cool. So where was I? Yes, and you can also get some countries. So give me some country.
Czech Republic.
Slovakia.
Czech Republic. Somebody was faster. I wanted to do Slovakia, and it's something about 10 million. So you have some idea how does our application under test work. We will get to it very soon, but now I want to show you what is PyTest capable of. So here you see my fake live demo, and firstly I want to show you collection. Before tests can be executed, they have to be collected to create the whole suite that will run. So PyTest takes care of that. Oh, there is a problem. I was ready for this. So we will create. I'm doing this as I speak. Don't be fooled. I'm actually typing. So tests are basically. Oh no, it doesn't work. You cannot see the upper.
I think you need to run it with the same resolution.
There's yellow color.
Yeah, it's river resolution.
Use a blind book. But it works.
So maybe I'll just switch it to full, and maybe if you don't see the beginning, I mean, it could be important. But right now it's even worse without the beginning. So let's try it like this. So basically, the moral of this story is that you should prepare for your presentation properly. But what I want to say about collections is that we defined two Python functions, test lazy and lazy test. So,
by the way, we have the same problem with that left side. So could you change your resolution, please?
So, I can change resolution. That might work.
Maybe it will be
just
good in
move the
videos.
windows.
But then the replay is broken. So let's try doing like
I
that.
think the replay is broken because the text size is too large, and therefore you don't fit as many characters on the line.
Let's try now. Oh.
Jumping.
Oh.
No.
It's about the text size.
Yeah, probably right. So everybody can see now. I will pray it works. I don't have anything else left than praying.
Praying and fighting.
Basically, I created this file, and it has two Python functions: test lazy and lazy test. And the only difference between them is that one starts with test underscore, which is something that pytest considers to be special and collects. And all the Python functions that start with this are considered to be test method. So now, if I call pytest in this folder, collect only. Oh, I have many tests there, so I will call it only on our file. You can see that test lazy is collected for execution, but not lazy test. So this is the first thing. When we have the test collected, how do we verify that the program under test fulfills our expectations? So let's hope it works. So far so good? No. No.
Maybe you need to
It's quite bad, so I won't type it live. There is no way I'm gonna do that, so I will just show you the final file. This can be, I hope, seen. This is good. So, once again, we define Python functions that start with test, and then I just generate some random number between 1 and 10, and I use Python keyword assert, and assert that the test input is greater than 0, for example, if this is our condition for successful test. This is of course very stupid, you won't do that in real production, but you can have some idea. It's especially interesting for people who come from like Java frameworks, etc., where you have specialized assert methods. So you always assert greater than, assert equal to, or assert string in. So here you just use simple assert and specify the expression. And another advantage of this approach is that you can define test steps. So for example, in the last test, I have one assert, second assert, and third assert. And when each, if one of them fails, we know exactly when we failed in the test execution. We also can specify strings that will be displayed if our test fails. So when I run this, oh no, I'm doing live demo anyway. You can see that first two tests passed and the third test failed, and we see first assertion was okay and second assertion failed. We tested that current year is smaller than random number, which is 1 to 10, which obviously was wrong, and here we can see the real test result. So this is very, very good when you are then inspecting your run.
Yeah, I would just note for the beginners that using multiple asserts in one test method is kind of anti-pattern.
It's functional.
Yeah.
Also, you should use random values as input for tests.
I mean, these are not real tests. I hope that everyone understands that. Yeah, this is not the quality engineering I do at my day. I'm serious. I hope you know it. Yes, what's another file? It's Fixtures. Fixtures are another powerful thing that you can get from pytest. And here I have very simple example. So fixture is actually prerequisite for the test. If you need to have some value at your disposal or to have some object at your disposal, or if you need something to happen before your test is run, you can use fixture for that. So for example, this test length expects to have some list that has 3 elements. So I define a Python function called sample, and I decorate it with pytest fixture. This is the way to tell pytest, okay, this is a fixture, you understand. It returns list with 3 strings, and then both those tests, if they use it as an argument, can leverage and use this fixture. So here I assert that the length is 3 elements, and here I assert that each element is a string. So let's run it. And you can see it passes. And the last file I have for you is scope of the fixtures. So fixtures can have different scope, and I will demonstrate it like this. This cheap fixture just generates random number. Yeah, it is very cheap operation. It can be done in a millisecond. This expensive fixture simulates starting of some server, let's say, or some operation that takes a lot of time. I'm actually not starting any server. I'm just sleeping for 3 seconds. And word of caution, you shouldn't put sleep in your test, so don't try this at home.
At home you can.
At home you can, not at work. And here I just return the string that server is ready and running, yeah, just mocking some starting process. Here I have 2 test methods, test ready, which uses cheap fixture and expensive fixture, and test running, also using cheap fixture and expensive fixture. So the default scope of fixture is function. So for each test function, all the fixtures are provisioned again, or like for the first time. I will demonstrate it right now. So you can, test ready is executed, test running is executed, and you can see that it took 6 seconds because the expensive fixture was actually executed 2 times. If I go back to the file and change scope of the expensive fixture to module, it will mean that this fixture will be executed only once, and all the following tests that use it will just reuse it. So let's try, if I'm not lying. Test ready is running, and this test running also, and you could see that it only took 3 seconds. So if we need, for example, some server to be started, we need to happen for it to happen only once. So originally, now I would write some test methods for my program, but I think that because of my fake videos failed, I don't have any more time for this. So I hope I at least gave you some idea what pytest can do for you. Do you have any questions about this basic functionality?
I use the fixture in the first test and modify it. Does it modify it also in the second test?
The fixture? Well, yeah, you could do that if it has like module scope, for example. But I think unless you have very good reason to do that, I don't think that's a good idea.
Yeah, I mean, I should avoid modifying it.
Yeah, probably yes. Yes. So before I give word to my colleague, I want to show you one last thing, and I want to show you that PyTest is very customizable, and many plugins have been created for this. So I can run all the tests I have in this directory, and you see there is like, I don't know, 13 tests, 12 passed, one of them failed. This output is actually quite nice, from just directly from the PyTest. You can easily see what happens. But if you have, I don't know, 5,000 tests, you maybe want something more fancy. And for this, there is a customization PyTest HTML. So you install it very easily, just PyTest HTML. And then you can run the very same command, and you just use parameter HTML equals, let's say, report HTML, and the report will be generated in that file. So let's give it a second, and let's try to look at the report. You maybe don't see because it's quite bright,
Yeah.
but here you can imagine that there is a lot of test cases, their status, the reason why they failed, their counts, etc. If you can't see it, it's very nice. I can't even describe it. So, with enough embarrassment on my account, I give word to my colleague Lucie Leistnerová, and she will tell you something more about customization of PyTest and how it looks in real life.
No, thank you. Okay, hi, my name is Lucie, once again. I work at Red Hat for 2.5 years as QE, and I see many people I know here. I'm like only tester. We have our own testing framework that we use. So I know only how I use it. So if you have questions for how is it really done in the background, I don't know. Sorry. But for the customization, because our project is really big and we have many teams that are working on one project, it's like network, storage, and we are core system. So we use in the PyTest the PyTest marks. That means that you can put on the class, testing class, or on each method for the class, you can put your own mark that you define for the PyTest. So we have, for example, tiers. There are special type of tests that are marked like, I don't know, the unit tests are like tier 0, component tests are like tier 1, and so on. And also we have marks for the teams, network, storage, and core system. And then with PyTest -m, the option, you can say which mark you want to use, and only these tests are collected and run for you. Also, we have some upgrade tests, and then there we specify which tiers are run after upgrade of our product and which are run before. So there are the marks you can define. Find it on Google. There are really nice examples. And the second really nice thing we use there are PyTest plugins. There you can, for example, we have Bugzilla. Don't know who knows the Bugzilla. There are bugs you can enter there, and developers are fixing them, and we then are verifying that they fix it correctly. And the PyTest we use, it's connected with PyTest plugin that are special defined methods. Like, sorry, I have notes here in the phone because I can't remember. It's like PyTest run test setup. That before you run a test, there is a setup that you can do anything like with the config, set values, or do something, and then it's the special test run. So it's done before every test you run. And there is also PyTest add option that can put some special option for the PyTest. I will explain that. And pytest configure, it's in this function, you manage the plugin that you use for that. And with the Bugzilla, we put in the pytest mark, in the decorator, we put the ID of the Bugzilla, and all it's done like magic with the Bugzilla plugin, because pytest has special Bugzilla module that is used there. It's like you put there the Bugzilla address and credentials, and it will get the special bug with that ID and gets its comments and summary and everything you need. And if you mark that with the Bugzilla plugin we use, then when we have defined that when this bug special it's not in OnQA or verified status, then the test is skipped. So it uses, every time the test is run, it uses Bugzilla and checks the status of the bug that is connected with the test and can skip it if it's not done yet, it's not fixed. So Bugzilla is really useful. One thing we use very often. And another thing is that we have some testing system called Polarion, where I know I was working with that today, and I was very creepy after that. But it's a really nice system, and we create their test plans. Test plan is some set of test cases, special ones. And from that test plan, you can do a test run. That means that it copies the test cases, and you go through the test cases and say passed, failed, what is wrong, like in that one. And with this customization for us, you can also mark a test with this Polarion. You put there the ID of the Polarion test case, and then after all the tests are run, it will create JUnit with special information for the Polarion. So it put there the ID, it put there some other things that Polarion needs. There is also the result of the test and something like that. And from that, the JUnit is created there with our Jenkins job. Don't know much, but it will create the run for that test plan with these test cases. And there are many other things that you can program and customize the pytest for your project, especially. That are the ones that I know I use every day. And all for me. Thank you for your attention.
Thank you very much. I hope we didn't scare you from pytest. If you want to take two things away from this presentation, pytest is quite easy to get into, but also very powerful, even if you have big projects. And if you want to make live demo, just prepare